Assalamu alaikum. Welcome to the second lecture of data mining, CS 432 and CS 536. Uh, in the last lecture, we discussed the modalities of the course, and we also introduced the course as well. We started talking about data mining, the need for data mining. We also defined data mining, and we also discussed the standard Kdd process, uh, the knowledge discovery from database process. Uh, the agenda for today is we will wrap up chapter 1 regarding introduction to data mining by giving some uh, categorizations of data mining, uh, and following that we will then start with uh, data understanding, which is one of the first steps in the data mining process. Along the way, I will also introduce another data mining process, which is called the CRISP DM, which is more commonly known in the industry. And we will be kind of following that process uh, while we discuss the various topics in this course. Uh, so are there any questions before I get started? So the recordings of the lectures are available on YouTube. The last lecture is now available. Just search for, uh, you need to search for the channel Kdd Lab Lums. So let me share the screen. So if you search for Kdd Lab Lums, so you will find the YouTube channel. So the last lecture is now available on this channel. Actually, all of these lectures will be part of a, uh, I don't know what you call them, a series. So you will find them all in the series for CS432 Spring 2022. So the first lecture has already been posted. New lecture will be posted during the day, later in the day after the lecture. All right. Any other question? So can you guys see my screen?
Yes.
Yes, sir, it's visible.
ठीक है. All right. So let me quickly wrap up the first chapter regarding the intro to DM. So data mining can be characterized in various ways. Uh, and some of these ways are highlighted or mentioned in this slide. So based on the type of data or the data that you are mining, you can call it as relational data mining or web data mining. Web actually is also application area. You can call it graph data mining. So this is all based on the type of data or the data on which you do data mining. So you might have heard these names before: graph data mining or relational data mining and temporal data mining. So all of these terminologies are based on the type of data on which data mining is done. So another way of characterizing data mining is based on the knowledge that is being mined or the specific task that is used to mine data. And we'll talk about task briefly in a couple of slides. So these are all tasks in data mining: characterization, summarization, classification, clustering, outlier analysis, um, as well as temporal analysis and so on. So data mining can thus be called clustering or can be called classification and so on. We'll also briefly later talk about predictive and descriptive data mining because some of these tasks fall into predictive data mining and others fall into descriptive, and some actually can be both predictive and descriptive. We will mention this when we discuss these tasks in a bit more detail. So application wise, you can also characterize data mining. As I mentioned before, you can have web data mining, text data mining. So also based on this industry sector on which you apply data mining, you can have data mining, financial data mining, or for example, telecom data mining and so on. All right. So this is just kind of highlighting the various, the breadth of data mining based on the data, the application, the knowledge, and so on. So we have briefly mentioned the types of data sets before. So this slide highlights some of them again. Uh, so you can have data mining done on a relational database, on a data warehouse, on a data lake, on a data cube, on a graph database, on, for example, the web as well, which might be considered as a database. So you can also have data mining done on streams, which are continuous flow of data. So in which we can call them stream data mining. And also if the data is sequential or time series or spatial temporal, so you can have time series or spatial temporal data mining. So some data can be more structured like graph data or network data. So mining such would then be graphical data mining or graph data mining. And of course, data mining can be done on multiple different types of data as well. Not necessary that you do data mining on only one type of data. So usually the data could come from multiple sources, from multiple types. For example, if you consider the web as a database, it has all kinds of information: textual information, image information, audio information, uh, links information, and so on. So data mining essentially is using all available information to find relevant pieces of knowledge that are potentially actionable, useful to the end user. So we talked about data mining functions. So let's briefly discuss them in slightly more detail. So data mining functions are also called data mining tasks. And there are about 5, 6 well-defined tasks in data mining. The first one is summarization and characterization. The second one is, of course, there's no order in them. Uh, of course, just mentioning them in arbitrary order. Summarization, characterization, clustering is another task. Classification, regression. Classification and regression are often labeled together, considered together because they represent supervised learning. And then we have outlier analysis. We also have time series analysis and so on. So all of these are tasks or functionalities or functions in data mining. So generalization or summarization basically means that you are trying to understand your data in some summary form. So you can say, given any data, you want to extract the high level information from that data, some higher level extraction of the data. So that is generalization. Okay, I think this is still the previous slide. Let me go forward. Okay. So generalization, characterization, or summarization. So basically, as I said, trying to get a bigger picture of the data or a high level view of the data. So you can think of in a very simple sense. For example, if you have one attribute, like let's say the price, the stock price for a particular company, one very simple way of characterizing that uh, stock price is to give one value as a representative for all the prices in the last year. So that one value, for example, could be the mean stock price in the previous year. So that is a very simple example of characterization. Of course, characterization, summarization would depend on the type of data that you are trying to characterize or summarize. For example, if you have textual data summarization has a specific meaning. So if you have a long passage, you want to generate a small passage that contains all the relevant information from the longer passage. So that is summarization in the context of text summarization. But if you have any other type of data, you will have a relevant, appropriate notion of summarization or characterization. So another important data mining function or task is association mining or frequent pattern mining. So essentially, in this case, what we are trying to find are events that occur frequently together. And from those events, either frequently or infrequently also, although infrequently usually are not very interesting. So that's why you will see mostly people mentioning frequent item set mining or frequent pattern mining. But sometimes infrequent is also interesting. So frequent patterns means that events that occur together frequently, and from those events, you might then develop associations. If A occurs, then B would also occur, or if A occurs, B occurs with a certain, let's say, probability or confidence. So this is another important task, and there are various applications of this. Usually, its application comes from transactional databases. You can think of uh, e-commerce or a retail store for example, like Carrefour. So people carry out baskets of products. They check out. Each basket contain multiple items. So the co-buying of items is thus the pattern that we are interested in. So what is the frequent co-items or combination of items that people buy? So for example, if people buy tea, would they buy, for example, every day with it or not? Or in other words, is every day and tea a frequent combination of item that is bought or not? So such kind of things or discoveries are done through association mining or frequent pattern mining. So from these patterns, you can derive other things like associations or correlations. And in some cases, it is correlation. In some cases, it is not. We will see this later on in detail. So this rule that is mentioned here, diaper, means that you are buying beer as well. So this was discovered in the late 1990s by Walmart. So which is kind of interesting because you don't seem to have any relationship between them. But somehow someone who comes to buy diapers would also buy beer. Of course, this is in the context of United States. So, so this is an interesting piece of knowledge that was discovered historically through data mining. So that's mentioned here in this slide. Anyway, we'll discuss this in more detail. This is a main component of this course. So the another task is classification, and classification, of course, is also used. It comes from machine learning. So classification is supervised learning. The idea is that given data, you build a model for predicting something or to find something as an output. Once that model is built, you can use it for new inputs to predict the output. So one quick example could be, uh, uh, so for example, if you have, there could be several examples. Classification is very popular. So just trying to think of something that's interesting. Uh, so let's say if you have customers buying at Carrefour, for example, uh, and you want to determine whether a particular customer, let's say A, would purchase a particular item Y or Z. Let's say customer A would purchase, let's say, a laptop. So, so based on the preceding history of the customer and what other customers like A do, you try to predict whether he or she will buy that particular laptop or not. So you learn this model first, and then given the information for A, it will tell you with some confidence whether that person will buy the laptop or not. So this is, in general, building a model and then using it for prediction. So in this course, we would not focus too much on classification because this is covered extensively in other courses, for example, in machine learning. I will only introduce a bit uh, you to a bit of classification and decision tree learning, which is which is a popular technique for classification. Similar to classification, of course, is regression. Regression is not mentioned in this slide, but regression is trying to predict an output which is continuous. So maybe you're trying to predict the stock price for a company tomorrow. So now the output, the predicted value is continuous. In the previous case, we were trying to predict whether a person would buy a product A or not, yes or no, which is a binary label. So that is regression, which is very similar to classification. So moving on, we have clustering. Clustering again is a name that comes from machine learning, and it's generally characterized as unsupervised learning as opposed to supervised learning for classification. And in this case, basically, we are trying to find, given some data, we are trying to find groupings in the data automatically. So groupings in the data are found automatically using some intrinsic uh, properties of similarity between the data objects. So the output of clustering would be some groupings of your data objects in the data set. And the idea would that within a group, objects are similar according to whatever notion of similarity that you're using, and objects between clusters are different. So we will be spending a fair amount of time in this course on clustering as well, discussing both machine learning based approaches, algorithmic approaches, and we will talk about evaluation and other related topics to clustering as well. So another function or task is outlier analysis, which is also sometimes called anomaly detection. So outlier or anomaly is any object, any data object that is significantly different from the rest of the object. And so the idea in anomaly detection or outlier detection is to, first of all, find such anomalies or outliers in your data set. And again, it has many applications. In the case of the customer example that we are looking at, you can think of anomalies as, for example, someone buying an extremely expensive item in the store, which is a rare event. So that would be an anomaly. Or it could mean that a particular person A, now on a particular day and time, suddenly buys a lot of things, while his or her previous history tells us that he or she does not buy too many things. So that's a sudden spike in buying. So that might indicate a fraud. For example, someone has stolen his card and using it to buy a lot of things. So outlier analysis, it's basically trying to find such incidents in data. So we will be discussing outlier analysis as well in fair amount of detail. So another important task or functionality in data is trend or time analysis. So many of our data sets nowadays have an element of time in them. And whenever you have time, so there is a notion of evolution of activity over time. So those evolutions may exhibit certain characteristics. So for example, buying behaviors might exhibit certain characteristics at a particular store. So again, taking the example of Carrefour, so you might have a spike in buying before Eid, for example. And Eid is a periodic event. It occurs at specific times of each year. Or for example, let's say at Carrefour again, they have promotions conducted, and usually promotions may spike up purchases. When there are no promotions, purchases might be low. So such patterns or detecting such patterns from data is basically uh, temporal analysis. And there are many shades of this, and we will discuss some shade, not all, not very detailed in this course as well. Time series analysis, spatial temporal analysis, we will discuss in this course. So then we have network or graph analysis or graph mining. This can also be considered as a task or function in data mining. So in this case, the major difference is that since your data set is structured or highly structured, actually most data sets are somewhat structured. In this case, they are highly structured, and you also have relationships, strong relationships between objects. So you can find more interesting information. So you can think of the web, for example, as a structured data set. So you have one page A, another page B. If A has a link to B, so there you can assume A page to be linked to B. Similarly, A might link to other pages as well, C, for example. So all of these pages would then be connected as a graph or network. And then you can, of course, analyze this whole information as a whole together. So several things can be done. You can find, for example, pages that are highly linked or cited, for example, or you can also kind of indirectly verify the quality of the content on a particular site based on how others link to it. This is, of course, a famous page rank algorithm. And then, of course, there are other analysis that you can do. You can find cliques for example, groups of pages that are fully connected. And also you can do pattern analysis, how frequently are pages fully connected in your network, and so on. So graph analysis, we will talk about some algorithms in graph, but not all, not too much detail, not all aspects, of course, but we will look at some graph mining algorithms in this course. Okay, I think I will skip this slide, and not all slides are. Uh, we will discuss evaluation in more detail. Is a very important aspect, but I think at a later time. So I think you're all familiar with this slide. So data mining, it's a confluence of various disciplines. Machine learning, of course, is one of them. Statistics, probability, high performance computing, visualization, maybe as well if you want to take visualization as a graph, as a field, databases. So all of these contribute to data mining. So I will skip this. In general, there are lots of application of data mining in almost all domains. The bottom line is wherever you have lots of data or data, you can do data mining. So that's the bottom line. And you have data everywhere nowadays, in the social sciences, in the pure sciences, in the industry, in all segments of the industry, from manufacturing to financial markets to uh, whatever you can think of, astronomy, for example, bioinformatics. So you have data everywhere, and you will have, of course, data mining everywhere. I will also not go over the major issues. We will be discussing these issues as we discuss the algorithms in this course. Issues are usually related to, of course, scalability and efficiency of the algorithms. So finally, to conclude the first chapter, introduction, a brief history of data mining. We had mentioned some terminologies and history before as well, but specifically if you talk about the data mining as a name or as an academic field, so data mining was started with this name as a workshop in an AI conference, IGCI, in the late 1980s. So data mining became an independent academic conference in the early 1990s. And since the mid 1990s, it has become an established academic conference as well as venue for publishing and research. So you have now lots of dedicated journals as well as conferences focusing on data mining research. And of course, there are also industry-focused conferences as well. So of course, the top conferences, some of the top conferences are listed there, for example, KDD, ICDM, ICDE, VLDB, and so on. Nowadays, we have also WSDM, Web Search and Data Mining, also very popular. And of course, the AI conferences also have tracks on data mining. Talking about industry, there are lots of information on the web regarding data mining. Uh, so you can always Google search for interesting blogs on data mining, you'll find them. And most of them, or many of them have interesting information. I will just mention this site to you. This is an old site actually, old in the sense that it was started in the 1990s. And I used to follow this way back in the 1990s, early 2000. It's still around. So this is actually, you can think of it as a portal, KD Nuggets, knowledge-discovery-nuggets.com. It has a collection of information, interesting articles, industry trends, new software launches, other things. So for example, 6 data science technologies to build your supply chain solution. What happened? Okay. So top programming language, so on. So it's always an interesting read. So you can subscribe to their newsletter. I think they send out a newsletter every week. But if not, you can just go to the website and read the articles, look at what is happening in the general AI, machine learning, and data mining community. And of course, there are many other such sites. I just mentioned this because this is one of the first one. And it's something that I used to follow quite a lot. All right. So any questions so far? All right. Uh, all right. All right. So let's move on. Let me. Uh, all right. So we discussed the KDD process earlier on. And if you recall, the KDD process started from data on the bottom left, and then you had straight lines going through various components like selection of data and then pre-processing, and then you had the actual data mining module, and then you have evaluation, and then you finally have the patterns for that you actually use. So that is fine, but there's also uh, a couple of relevant standards in the industry that try to uh, standardize the data mining process. Of course, they have tried. It's not like the, you can say, the de facto standard, but it still gives you a good idea of how data mining should be done to get good results. So one such standard is the CRISP DM, which is basically cross industry standard process for DM. So this is kind of uh, marketed or promoted by several companies and top companies, including IBM and others. There is one other competing standard, which is, by the way, very similar to this, so I wouldn't go into that. Uh, the main thing that I wanted to highlight in this standard is it defines several stages of processing. Uh, so those stages are helpful uh, in understanding your data mining project and kind of pacing your data mining project in a proper way. So those stages are, let me write them here. The first one is data understanding. So let me first write them all. So then we have business understanding, Then we have data pre-processing. Then you have modeling. And then you have evaluation. And finally, deployment. So these are the important stages, you can say, in a data mining project. So basically, you start with data understanding. Everything begins with data. So you need to have a better understanding of the data, from where it is coming from, what is the quality of the data, what are the key characteristics of the data. Are there any significant, for example, missing values, for example. So many things. You need to generally assess the quality of the data and try to understand the data, whether it makes sense or not. So we'll discuss this in detail, the notion of quality and so on. So along with this, you also need to understand the business that is generating that data, the domain that is generating the data. So that is business understanding. So data mining cannot be done effectively without understanding your business or the business that is generating the data. So data mining cannot be done again in isolation from the company or the institution or the process that is generating the data. So one common notion is that if you have a dump of data, without knowing where the data is coming from, you can do data mining on it. So usually you will get spurious results, results that are meaningless. So you need to relate your result back to the original process that is generating the data. So that's why business understanding is very important. And in good data mining projects, you usually need to have close working relationships with business personnel, business analysts, and so on. Pure data scientists may have problems, first of all, designing their data mining solutions, and then, of course, interpreting them. Then after that, you have actual data pre-processing. So once you have understood the data, you have done the business understanding, you need to shape your data uh, according to what you want to get from the data. So this is all pre-processing. And pre-processing is like a bunch of things, and we will discuss all those bunch very briefly. Lots of things can be done in pre-processing. Anything that is done now without anything that's done now at this stage before you actually apply the main data mining algorithm is called pre-processing. So after pre-processing, this modeling, this is where you do the main data modeling and application of the data mining algorithm. So this is where you have, for example, association mining or classification or clustering or outlier analysis and so on. So that's the modeling part. And then after modeling, we also talked about previously, evaluation is very important, both automatic evaluation as well as human evaluation. So whatever you get as output of your data mining algorithm, you need to verify whether it's interesting or not. So, so if it is interesting or not. So you might have some automatic measures to do that, which we call interestingness measures. And then after that, eventually humans have to verify whether whatever has been found is actually actionable or not. And then finally, of course, for many data mining projects, you need deployment. You actually need to deploy a solution as a working solution for everyone to use, for the relevant people to use in their daily activities. So this is crisp DM, and they divide the data mining process into these stages. And as I mentioned before, these stages are not linear from data understanding to deployment. They might be loops. So iterative approach has to be followed. And since evaluation involves human beings, so it's also interactive. And you might have various visuals that you need to look into and decide whether something is relevant or not. All right. So is this clear?
Yes.
Okay. As just a you can say short homework, you might look into uh, Google search for other analytics / DM standard processes and try to find out how those processes differ from this CRISP DM process. So there might be minor differences, as you will see. So you can search for such processes. Sometimes one of the reasons for developing these processes also for interoperability. So let's say if you have built a data mining solution at one company, maybe you can port that solution to another company with little modification. So one of the goals for developing these standards was that, although that's not always 100% possible, but still, if you standardize as much as possible, then you will have to do less work to port your solution to another company. All right. So any questions so far? So let's move on to data understanding. So this is chapter 2 in your textbook, both textbooks, Introduction to Data Mining and Data Mining Concepts and Techniques. The idea in data understanding, as we had already mentioned, is to gain insights into your data, and through the data, insights into your business, which is, of course, also the goal of data mining. All right. So first of all, what exactly is data? Very quickly, data is anything, any information that is recorded. So you have studied databases, most of you. So you know that data is any information that is recorded, we can call it as data. And a database is basically a collection of data, and usually that collection is ordered. Sometimes we also call it a data set, right? So there is some structure in any database or any data set. And depending on the type of database or data set, which we had mentioned previously, some of them, that structure might be somewhat different. All right. So we will quickly start with the standard uh, data matrix, which you can also call is the relational database. Although relational database have some other stricter conditions, as you must have studied in databases, but still you can say is a tabular data. So what is in a tabular data? You have rows and you have columns, right? Rows basically represent data objects. So each row has information on a specific data object or entity. So for example, if you're talking about customers, each row would have information for a particular customer, one entity in the real world. So if it is something else, let's say if you're talking about one row representing one web page, so it will have information regarding that one web page. So rows are also sometimes known by other names. So so you can call them, in the database terminology, you can call it a tuple as well. You can also call it row, of course. You can also call it example. This is more common in the machine learning community. One example, one instance, for example, also is used. So multiple names can be used for the rows that are in a data matrix. So now columns. So columns basically capture specific pieces of information for that particular data object, for each data object. So that specific feature is often called an attribute. And of course, for each data object, there might be multiple attributes. And in addition to attributes, you might call them with other names, for example, feature. Sometimes we also use the word dimension. Sometimes in the pure statistics community, they also sometimes call it variable because this is a variable that varies across all the data objects. So there might be other names as well. All right. So at the end of the day, you might have n rows and m columns. So this is a 2D matrix, data matrix. Each row represents a different data object. Each column gives you the value for a specific attribute for each object. So for example, if I want to let me define a database with a name as an attribute, age as an attribute, and gender as an attribute. And then we have various rows. So maybe we have ASIM, and we have some age here, let's say 50. And then you have gender M, and then there might be someone else, Asif, age 35, let's say M. Then we have another Asifa, for example, age 18 and gender female, and so on. So this is a data matrix, a tabular representation of data, and one very common way of capturing information in a data set. All right. Any questions so far? All right. So now let's quickly go over data attributes, their types and their characteristics. And then we'll quickly discuss some ways of characterizing. Remember we talked about characterization? Name, age, and gender attributes, yes. So you can also think of as attribute value pairs. So for example, if you talk about the first row, so we have, for example, age, and then you have 50. So this pair is basically the information or data for the first object. We have the first information is age and the second is value. Okay, so about attributes or features or dimensions or variables, so there are various types. And there are also various categorizations of types. So the most common, and of course, these characterizations often would overlap, as we will see. The most common is, of course, numeric vs categorical. So we can have numeric attributes or categorical attributes. And the distinction between them, the primary distinction is numerical attributes have values that are represented by numbers, and categorical attribute have values that are represented by symbols. Okay? So attributes, numeric would be numbers and categorical would be symbols or labels. And of course, you are familiar with some of these. So this categorical attributes can further be categorized as nominal, ordinal. Actually, these are for numeric. So okay, numeric का ही कर लेते हैं. Ordinal, yeah, okay, ठीक है. Ordinal, then we have interval, scaled, and then we have ratio, scaled. So these are common further categorization numeric attributes. Of course, ordinal is not really numeric, so I'm kind of mixing these up. So this is, you can say, another categorization. So you can categorize as numeric or categorical, or you can categorize as ordinal, nominal, and interval scaled and real ratio scaled. So let's look at these and further categorize them. So first of all, nominal. So nominal values or attributes have labels that can only be matched with each other. So there, no other operators can work on them. So the typical example here is, for example, gender. Gender may have values, let's say M and F. So M is a value which is a label, which is a symbol. F is a value which is a label or a symbol. And no other operator can work on them other than equality. So if you want to compare two data objects with regarding the gender values, you can only say whether they are equal or they match or they do not match. So M would match with an M while M would not match with an F. That's it. So this is the only operation that you can apply on them. So ordinal attributes are usually categorical. And what is a categorical attribute? Because it has a label assigned with it. Okay? So mostly we have categorical attributes and as ordinal. A specific case of ordinal is called binary attribute. So binary attribute has only two possible values. Okay? So in fact, जो gender मैंने ऊपर discuss किया, that is a binary attribute in this particular setting. There might be other attributes, let's say color. If you define an attribute color with values RGB, for example, it has three possible values. So that would then be basically a nominal attribute with three possible values. So the number of distinct values possible for a categorical attribute is also sometimes important. So we will usually keep that value in mind as well. So number of distinct values for categorical attributes. So for example, gender, as I mentioned above, have two distinct values. Color, RGB, has three distinct values, possible values. And of course, if you're coming from a database domain, database community, we sometimes call it as the domain of the attribute. The possible values come from the domain of that particular attribute. Okay? So this was ordinal, nominal. Then look at ordinal. So ordinal attributes can be compared. In addition to being matched, they can also be compared. And the typical example here would be given as grade. So grade can be any value from A, B, C, D, and E, for example, or let's say F, for example. So the attribute grade can take on one of these five values, A, B, C, D, and F. So these are not, these are of course labels, categorical attribute, but they now have some more relationship among them. So you know that A is, according to the domain, better than B. Or in other words, you can order the values. So in ordering is possible in addition to uh, simple matching. So ordinal provide more information, ordinal attributes provide more information than nominal attributes. And again, usually these are categorical, but not always. So for example, age oftentimes is given in whole numbers. So usually this is an integer. So age is an integer. So integer, of course, will be 1, 2, 3, and so on. So in this case, it is nominal, yes, but it is not necessarily categorical. It's a numeric attribute. So as I said, attributes categories may overlap. So you need to, one of the reasons why we are discussing all of this as a data miner, you should be able to understand the data. And from that understanding, be able to understand the domain. So, and also without understanding your data and applying data mining techniques, you might guess what we call as spurious results, results that do not make any sense. All right, so this was ordinal. Now let's go on to interval scaled. So interval scaled and ratio scaled, these are for sure numeric. They cannot be categorical. So they are going to be numbers. Okay? So interval scaled and ratio scaled are numeric. So interval scaled are numeric attributes in which differences between values make sense, but ratios do not. So differences make sense, but ratios do not. So the best way to understand this is these are arbitrary scales, meaning that these scales can be slided left or right. They don't have an absolute zero. So, and the usual example given here is of the temperature scale in either Celsius or Fahrenheit. So Celsius, 0 degree, 0 Celsius does not mean absence of temperature. So it doesn't have an absolute zero, it's relative. So in this case, of course, if you have a temperature of 10 degrees and you have a temperature of 20 degrees, the difference is, of course, 10 degrees. And similarly, if you have a temperature of 5 degrees and you have temperature 15 degree, difference is again 10 degrees. So those differences make sense. But the ratios would not, because you don't have an absolute zero. You can't say that in the first case, so 10 and 20 means that if you divide it, so you have, so 20 degrees twice as big as 10. What you can say that it was twice as hotter as 10 degrees. You can't say that, or twice as warm as 10 degree. While in the next case, 515 would give you 3. So it is thrice as warm as 5 degree. So you get different numbers, and those numbers do not make any sense in terms of that particular attribute. So these attributes are called interval scale. They are numeric. And again, why we are looking into this, because later on we'll be applying various data mining techniques on them. And if in the data mining technique there is calculations regarding ratios or some analysis done on ratios, you need to be aware that those ratios may not make sense and might give you misleading results. So finally, we have what is known as ratio scaled. So most physical quantities that we have today are ratio scaled. And of course, again, these are numeric attributes, not categorical. So again, taking the example of temperature, so Kelvin is ratio scale because its zero is an absolute zero, in absence of temperature. So 0K is absence of temperature. So, and of course, most physical quantities that we measure are ratio scale, for example, length, area, uh, whatever you want to think of, weight, and so on. So all of these are ratio scaled. Okay. So any questions so far? There may be other categorizations. So for example, sometimes we use the categorization continuous versus discrete. Sometimes we also use the categorization called qualitative vs quantitative. So, you need to be careful and assess the exact attribute that is used in the data and try to characterize it as precisely as possible. Because broad categorizations might lead to misleading results. Try to make it as precise as possible. And one of the ways of making precise is the ordinal, nominal, ordinal, interval, and ratio scale. And within nominal, we have binary as well. All right. So we have about 10 minutes left. Okay. Just trying to think what to cover next. Okay. So I think we'll come back to this later on. Thoda sa overlap is always good between lectures because there's maybe few things regarding quality and so on that we might discuss next time. So let me move forward and look at data exploration. So we talked about data exploration or understanding in terms of attributes and data and so on, but we would like to explore the data a bit more specifically in terms of numbers, or I would say exploration, I would say characterization. So in general, and we would like to characterize usually single attributes or single objects at a time, or maximum two attributes or maximum two objects at a time. Because this is our data understanding part. We are not worried about deeper analysis at this point in time. We just want to get some idea about the data to make sure the data is of high quality, make sure if there are no issues in the data. So we need some quick characterization ways. So there are two things that we typically look into. One is central tendency. Central tendency, and this is specifically with regard to attributes. And the second is dispersion tendency. And many toolkits that are available out there, for example, your Python and Panda, they automatically generate these stats for you once you load the data. So these basically are, you can say, stats for characterizing the data. So how can you characterize a central tendency? So you have several things. So you can use, for example, central tendency is basically given by the mean. You can also use the median. You can also use the mode. And of course, these are all stats and you are familiar with these stats, but you need to know on which attribute these can be applied. So can the mean be applied on a categorical data set or found for a categorical value attribute? So the mean basically is computed by taking the average, which is summing up the values and dividing by 2. So you have a ratio involved there. You have numbers that need to be added up. This cannot be done for categorical attributes. Similarly, median requires that your data set or your attribute values can be ordered. Well, mean is the middle value. And if it is even length, the middle two values, and its average, for example. So the median cannot be applied on nominal attributes or cannot be found for nominal attributes. The nominal attributes cannot be ordered, while it can be done for others, which are ordinal, interval scaled, and ratio scaled. And mode basically is the value that is most frequently occurring, and this is most appropriate for categorical data and especially for nominal categorical data. So we are trying to find the value that is most frequent in the data set. And mode generally, of course, if you have a distribution, you can plot the mode as well, but mode as a value for numeric attributes cannot be just one value. Usually it's going to be over a range. So all of these would give you some central tendency of the data. So where is the data centered around? For example, let's say आपके पास age का data है. Let's say age for students at LUMS, right? So how can you find the central tendency? Age is ratio scaled, and usually it is integers are used to use to encode age, but it's still numeric. It is still ratio scale. It has an absolute zero. ठीक है ना? तो इसका फिर आप मीन निकाल सकते हैं. Let's say for example at LUMS, if you compute the mean of all students, you might get a value like let's say 22.3 years. So this would be one value that is characterizing this attribute in this data set. And what is this characteristic? We can say this is kind of a central tendency. So similarly, again, assuming we have students and at LUMS, so if you say gender, gender is binary, gender is of course nominal. So यहाँ हम mode निकालेंगे. तो let's say mode हम निकालते हैं, तो we find that male is the most frequent. All right. So again, this gives you a quick idea about the data set. And similarly, if you have some GPA type of thing or grade type of thing, तो आप median भी निकाल सकते हैं. So इसके बाद dispersion tendency है, उसके भी इसी तरह के simple measures. I think I'll probably stop here. Dispersion tendency. And इसके भी कुछ छोटे मोटे measures हैं which we can compute quickly. All right, so I'll stop here and we'll start from here next class, and we will cover this more of these stats. We look at some visualizations, and then after that, I think maybe next class में हम pre-processing पे चले जाएंगे. Because I don't want to spend too much time in this part, because most of this stuff is basic. ठीक है, so any questions?